Okay, so this lesson is actually really short. It's all covering how to find the area of a parallelogram. So if you remember from last class, the definition of a parallelogram is any figure that has four sides and the opposite sides are parallel to each other. So when we find the area of a parallelogram, the formula is very simple. It's just base times height. So what we need to know about base and height is that the base is always one of the side lengths. And then the height of the parallelogram always hits the base at a right angle. If you did not write down either of those things, you need to do so now. So the base of a parallelogram is always one of its side lengths, and the height, just like when you find height of a triangle, the height of a parallelogram is always something that hits the base at a 90-degree angle. So it's never a slanted piece for the height. So finding the area of these first two parallelograms is pretty easy. The first thing we identify is that we know what the base is. In this case, it's 30. And then the length that hits that base at a right angle is 17. So to find the area, all I'm going to do is base times height. And if I multiply 17 and 30, we end up with a total of 510. Now, if this problem had units in it, then my units would be whatever they are squared. So feet squared, inches squared, and so on. So this one doesn't have units in it, so just answering with an answer of 510 would actually be okay. In the next problem, we have a parallelogram. There are actually two different ways we could find the area of this, so we're going to find it both ways and show that it's actually the exact same answer. So if I say that 6 is the base of the parallelogram, the length that hits that base at a right angle is this length out here of 8. So if I use those as my base and height, 6 and 8, I get an area of 48 units squared. Now, is that the only pair of lengths I could use as the base and height? In this picture, it's not. This 12 out here could also be listed as the base, and notice that this length here of 4 hits it at a right angle. So if I wanted to, I could say the area of the parallelogram was a base of 12 and a height of 4, which still also gives me an area of 48 units squared. So there are actually two different ways I could have found the area of this particular parallelogram. Moving down to the next two problems, what you should notice in each of these problems is that the height is missing in each one. I don't know what that height is, and I don't know what that height is. So in order to find the area of this parallelogram, I have to figure out the height. So the way we're going to do that is by looking at this right triangle over here on the left-hand side. And what we're going to use is we're going to use our knowledge of trig ratios. If I want to figure out what this x is, of this little gray triangle, the x is the opposite side from the 71, and the 13 is the hypotenuse. So I can use a sine ratio to figure out what the value of x is. And if you recall from last unit, whenever x is in the numerator, I'm going to multiply to solve. So if I do 13 sine of 71, we end up with an answer of 12.3. That means that this height in here is 12.3. So if I want to find the area of the parallelogram, the base is 28, the height is the length we just found. So I have an area of 28 times 12.3. By multiplying those two things together, we end up with a total area of 344.4. And again, it would be in units squared, depending on what the units are. The next one, again, we don't know what this height is, so I want to figure it out. There's actually a couple ways we can figure it out. Notice that this is a 45-degree angle down here, which means so is this one up here. That's a 45, 45, 90. And if you remember from what we learned last unit, the legs of a 45, 45, 90 are the exact same. So if this bottom leg here is 9, so is this leg that represents the height. So we don't even have to use trig in this one because just knowing about special right triangles tells us that the height has to be 9. So that means that I have a base of 15 and a height of 9. And if I multiply those together, we end up with an area of 135 square units. So the entire front of this was about finding the area of a parallelogram. The back side is about doing some things a little backwards. So notice in the first problem here on the left, you are told the area of the parallelogram is 7.2 meters. So if I start with the formula, A equals BH, I'm going to plug in what I know. The area is 7.2. The base of the parallelogram is 3. The height of the parallelogram is labeled as 3x. So my job is to solve for x. The right-hand portion, 3 times 3x is 9x. And if I want to solve for x, all I have to do is divide. Dividing by 9 gives me 0.8 as the value of x. In the next problem, it says, what is the area of the parallelogram shown? Now, what you'll notice about the two lengths given is one is the base and one is the height. So what I need to do is figure out, well, how can I take these and write them as the same unit so that I don't confuse myself? So let's talk about how many inches each one of these is total. 2 feet is 24 inches, plus the 3 extra gives me 27 inches. So 2 feet 3 inches is the same thing as 27 inches. 4 feet 2 inches, we would convert the 4 feet into inches by multiplying by 12. So I would get 48 inches. Then I would add on the 2 extra, and I get 50 inches. So I have a base and height, base of 50 inches, height of 27 inches. So if I multiply base times height, I'm going to get my answer in inches squared. So 27 times 50 gives me 1,350 inches squared. Now here's the issue. Notice that letter B says 350 inches. Now since that's not in the correct units, that can't be the correct answer. So what we're going to do is change 350 square inches into square feet. So let's talk about how to do that. In your science class, I would imagine your teacher probably taught you about unit conversion. So let's talk about unit conversion. Anytime I want to convert from inches into feet, I have to know that there are 12 inches in 1 foot. So I would be multiplying by 1 over 12. Now here's the issue. 1,350 inches squared has 2 pairs of inches up there, so I actually have to multiply by that fraction twice. The reason why is because using our algebra rules, these 2 inches cancel with the 2 inches that are both up there. So what we would do is multiply across the top, you get 1,350. On the bottom, multiplying, you get 144. So that gives us 9.375 square feet. And if we look back up top, that correct answer would be letter D. So that one had quite a few steps to it. Is that the only way to do the problem? It's not. We could have taken these original units and we could have put them into 2-point-something inches or feet and 4-point-something feet, which would also be correct to do. Moving down, let's go to the next problem. The next problem is a little bit of a word problem. So it says the area of a parallelogram is 507 square centimeters, and its height is 3 times its base. Find the base and the height. So let's talk about the area of a parallelogram. I know that the area is 507. Let's talk about the base and the height. It says that the height is 3 times the base. So if the base is x, the height is 3 times that, which means that the height is 3x. So if I plug everything in my formula, 507 equals base times height, x times 3x. Using our tools from Algebra 1, x times 3x is 3x squared. And again, using our rules from Algebra 1, we would divide both sides by 3, and we would get 169 equals x squared. Again, using our rules from algebra, in order to undo a square, we're going to square root. So I end up with an x value of 13. So this says find the base and the height. Well, it says that the base is just x, so the base is just 13 centimeters. The height, it says, is 3 times x. So that means I'm going to do 3 times 13, and I end up with a value of 39 centimeters. If you want to do a quick check and see, did I do this right, take the answers that you got from base and height, and if you multiply them together, you should get the area of the parallelogram that you were given to start the problem. Now, if I do that in my calculator myself, 13 multiplied by 39, I get an answer of 507, so I know that this has to be correct. Last two problems. All we're going to do is describe the error and correct it. So in the first problem, they're saying that the area of this parallelogram, they multiplied 5 and 6 together. So what I want you to notice is that 6 is the base, and they said that 5 is the height. Now notice that 5 is a slanted side. We know that anytime we talk about the height of a parallelogram, it has to hit at a 90-degree angle. So rather than hitting or using 5 and 6, we should have been using 4 and 6. So there's your error. Instead of using 5, that should be a 4 in there, meaning that my area would actually be 6 times 4, which is 24, not 30. In the next one, notice they're saying they're finding the area, and they did 7 times 4. Now, I'm going to agree with them that they used the correct height. What I'm not going to agree with is that they used the wrong base. They said that the base was this entire length down here. Well, just like with a triangle, anytime I'm talking about the base of a parallelogram, we're not talking about any extensions on the outside. So this piece here doesn't count when we're talking about the base of the parallelogram. The only part that counts is this 3 here. So rather than doing 7 times 4 like they did, that's the error. They should have done a base of 3 and a height of 4 and gotten an area of 12, not 28. So what you'll do the rest of class then is you're going to have an in-class activity to work on. You may work with a partner, and you're just going to have a lot of problems where you're finding areas of parallelograms and or answering some application type problems like the back of this sheet. If you have questions, I'm sure Mrs. McGee would be happy to answer those questions, so just feel free to ask.